Good afternoon. This is Mini Medical School, Part 1. We'll start with brain. This I recorded for Osher USF class for senior citizens. Now, we'll start from the top onwards and work our way down. And then we'll finish with some comments about other things such as precision medicine and stem cells, etc., if time permits. Now, as we all know, brain is an amazing organ. It actually really makes you think, how complicated it is. Okay. And this is the only organ where we use itself to study brain. This was called Lord Russell's paradox. This was a philosophical conundrum that he proposed, that consider a group of barbers who shave only those men who do not shave themselves. Supposing there's a barber in this collection who does not shave himself, then by this definition of this collection, he must shave himself. But no barber in the collection can shave himself. So it becomes like a mathematical and philosophical paradox. And believe it or not, there was an English neurosurgeon named Lord Brain, and I think they revised the name of his book. It was originally titled Lord Brain's Diseases of the Brain, but then I think it included more than just brain alone, such as spinal cord and other nervous system, etc. So they renamed it as Brain's Disease of the Nervous System. And here's a copy of it. You can see there's not making it up. His name was really Lord Walter Russell Brain. Okay, clever chap, obviously. Okay, but this is a new way to study brain, and this is some really sophisticated maps that are generated by the Allen Institute and Harvard. So it's done based on molecular medicine or molecular biology work, as to just see 1 cubic millimeter. It contains some exorbitant amount of information. That's 1.4 petabytes. Okay, so it's just so it's going to take us a few centuries to map the whole human brain, if ever. Okay, so about philosophy now, a word or two about embryology. That brain starts from a strip of cells called neural plate that folds, and from there on then just takes off, and into the classical 3 parts called forebrain, midbrain, hindbrain, and spinal cord. And the evolutionary process is amazingly rapid, that it's done by the stem cells, which are really the grandfather of all, and they multiply at a rate of almost 250,000 neurons per minute. And there are the part of, for example, your part that sees your vision is actually extension of your brain. So brain is so eyes are actually not just windows in your soul, but windows in your brain. You can say that and that's one of the reasons why doctors look at fundoscopy, to get an idea of the brain blood vessels. Okay, and that's in the reptilian brain is so-called level 1, which is oriented mostly in space. The brainstem level 2 is mammals, which have limbic system, okay, and some social relations and emotions. And level 3 is humans, and which actually does have imagination and times for future planning. So there are 3 different ways in which classically it was classified. And these 3 brains, when it folded on itself, it gave rise to, as you can see here, I talked about the olfactory tract, which is the part so the direct photons send the signal directly to your brain. And that's how we are connected to the windows. As human beings, we are primarily visual creatures rather than auditory, like bats, and smell like in other mammals. And the forebrain has several parts, which are the classical ones. Those who did anatomy or remember from the biology class will remember this is the cerebrum, which is the thinking part, and there are the empty spots called ventricles, and there is the midbrain, which is in the thalamus, which is like the relay center of the brain. cerebellum, which has to do with your balance, and the medulla, which has the vital centers. So, but we'll talk more about it as we go along. Okay, and but ancestry, we have to go back to the evolutionary, that some of the earliest parts of neural structure, neural crest developed in before even the vertebrates developed. So that goes back to the several hundreds of millions of years ago. And so that's the ancestors of all human beings, and all the mammals and phyla that are there are sea squids. And so the developing brain, it just folds on itself, so to speak. And this goes back before the amphibian days. So how they and this is tiny, a small sea squid that is attached to the undersea rock. So that there's some evolutionary basis for that, and actually some clever people had there was a guy named a scientist as well as a poet. He had written a poem that about it was probably not exactly one that you'd want to recite, but it was called the Axolotl and the Emoquote. Okay, so that was the ancestor of all vertebrates. And so that's enough about evolutionary aspect of the brain. And we are our brains basically, as there are varieties of genes that control the formation of the brain. And if those genes are not turned on at the right time, then you grow up with small brain called microcephaly. And we saw that with some horrendous outcomes during the Zika epidemic, which we may have even forgotten about Zika with COVID raging. Okay, and as you can see, that the size of the brain, and the smaller monkeys, it's about 70%, but in chimpanzees it's about 36%, and while human makes about brain size is small relatively, but it grows. So that's why there is a lot of growing to be done. Okay, to be outside, and then part of the things may be that the evolutionary advantage that we have gained over our cousins, which is chimpanzees, may be due to process of cooking, which provided calorie-rich food to the brain, leading to the growth. So there is something to be said about the evolutionary advantage, because the chimps have to eat for almost 8 hours to get enough calories for their body size. So there is some nutritional restriction that is imposed. Okay, and so brain is rather an expensive tissue to maintain. So okay, and so these are some of the regulatory genes, and some of the other genes which the chimpanzees have, are more prominent. They become weaker. For example, the genes for jaw muscles, so because or we're almost like, one can say, we are like baby chimps, so to speak, okay, and so the brain utilizes glucose, for energy consumption. Okay, so that just gives us an idea about the evolutionary difference between our nearest cousins. Okay, and again, this is, we already gave it the technical names, but to make it simply, the front part of the brain has got to do with speech and our planning process, judgment, all the complicated things that makes us as humans. Okay, while the parietal lobe, which is this part around here, as you can see, and that has to do with speech, visual integration, space and time. Temporal lobe, which has to do with auditory processing, face recognition, language. So these are the two areas which will be very important to remember, because they'll be relevant when we talk about stroke. And this may have to do with some emotional experiences, as like, and recently it may have some role to play in so-called out-of-body experiences. The stimulation of the temporal region gets this sensation. So there is some recent data on it. Okay, all right. So, and when you do the study, there is a brain more systematically. There is a bilateral symmetry. Okay, and the sensory output that comes, in two hemispheres. And so we have, as an adult, we have about 86 billion neurons. So you can say it's a huge number. The babies have even higher number because as you saw, the rate of growth was phenomenal. Almost like 250,000 neurons per minute. But by the age of 3, some of the neurons are pruned, and if there is not adequate pruning that takes place, that may have some role to play in illnesses such as autism. Okay, and obviously we'll talk later on about the plasticity of the human brain, and the remarkable capacity to make up for the damage that can occur as a result of injury or even due to birth defect. Okay. All right, and these are some of the fancier pictures of three-dimensional of the other parts, which are harder to visualize because they're on the bottom surface of the heart, so-called medulla, pons, which actually, all of these names started from Greek language originally. So pons just means bridge. It's like a highway-like structure between the brain and the body, known as the brainstem. And the brainstem is made up of 3 parts, basically: the midbrain, the pons, and the medulla. The medulla transmits a signal between the spinal cord and the higher parts of the brain, and controls our autonomic, means the functions that are not under volitional control, such as heartbeat, respiration, etc. Okay, all right, okay, and this just to say that there is more to brain than there is the rest of the nervous system, how the brain is connected to the body, not just with the nerves that take sensation and cause motor activity, but there are something called autonomic nervous system, which is the classical flight and fight response, which is the parasympathetic that makes us play dead, so to speak, and slows down the heartbeat, when may lead to fainting spells, and then again it contracts the bladder and makes us pee when we're scared. Or, for example, on the other hand, the sympathetic nervous system, which produces adrenaline, and when we're excited, our pupils dilate, heart rate accelerates. So all the feelings that you see when you are angry or in love. So these are some of the other pictorial platforms. It's an equally important system. And one additional thing that should be emphasized is something called the vagus nerve, which is vagus in Greek means wandering. That's the way the brain communicates with your gut. And it has a lot to do with a lot of other secretions that come from stomach, which are the serotonin and the other important, but there are about 100 to 150 neurotransmitters that are secreted. Okay, and this is looking at the more anatomy, because this is important to know, because as you can see, how the optic tract, crosses over, and that's why when the stroke occurs, the damage is on the other side, because the damage can occur in the middle type of thing, and the start switches over, the signal it's come from one side, and they literally cross over like a traffic junction. And at the base, so these are the nerve fibers of, and since we are so much important visual creature, vision occupies almost 1/3 of the processing centers. And so the visual stream is extremely important for human beings. Now, at the bottom, there are other equally important glands called pineal gland, okay, and pituitary gland, which secretes varieties of hormones, and which are the chemical messengers that are secreted. And there was one solitary organ that was considered a pineal gland, and since it was just only one, it was considered the seat of soul in the earlier 18th century. But obviously that wasn't as straightforward. And the brain has extensive 4 blood vessels that supply blood to the brain. The 2 in the front, which are called carotid arteries, and the 2 in the back that are called vertebral arteries. And this was in the early days of anatomy. This was illustrated by a well-known British surgeon named Dr. Thomas Willis as far back as 1625. Okay, and that's why it is named after him as Circle of Willis. And some of these brilliant illustrations were done by the polymath, who you may recognize as the man who built St. Paul's Cathedral, Sir Christopher Wren. Okay, so this was, and prior to that, you know, other anatomists in the Renaissance area had dissected the brain, but they were not able to distinguish between the vein and the artery. So they were close, but not quite there. Okay. And again, you know, the brain has tiny nerve fibers, and the neurons that are the individual neuron here, as you can see that the neuron which depends upon the electrical signal, so it works. And at the same time, there were some other theories as to how the messages are conducted. It's based with chemistry, which is the entry of the sodium and potassium inside the cell. Now, in the early days, there was enough of a controversy as to which one is the more important messaging system, as to the nerves, which are extremely long and can last for almost throughout the whole length body. These are called axons, and the nerve body, and they're connected to other neurons by something called dendrites. Okay, and so then there was a clever name that was given as to nerve fibers. What is important are the cables or the soups, you know? Okay, and then the two enterprising neuroscientists, they did work on large, you know, fibers from primitive animals. Okay, and the some of the, you can see their test animal is like a lobster, which had a large neuron that they were able to isolate and record, you know, put tiny electrodes inside and record the amount of electricity that comes out. And based on that, Hebel and Wessel were able to prove that yes, the electrical signal is actually involved, and they were the Nobel Prize winners in 1963. Okay, and at the same time, later on, the various synapses, the chemical signal, the neurotransmitters were secreted, which includes the dopamine and the workhorse of the brain called acetylcholine, which was discovered by some of the English physiologists. And so it turned out that both these ideas were correct. So both fields advanced separately, which includes neuropharmacology and at the same time electrophysiology. So both these turned out both of them were correct. Okay, and some of the interesting theories about, you know, this thing were worked out, you know, by a physiologist named Otto Levy, who got the idea during his sleep in 1921, and he woke up next morning and was able to try to reconstruct his dream, and then he, based on his dream recollection, he was able to devise an experiment and synthesize the chemical, you know, which turned out to be adrenaline and stimulant. So that's how he was able to, you know, so there are some interesting history behind it. Okay, and these are just a few of the neurotransmitters that you recognize, which is the adrenaline, which is the classical fight and flight neurotransmitter, noradrenaline, which is the previous chemical, and NOR stands for nitrogen on radical. It's abbreviation from German. There is no nitrogen in this particular molecule for the chemistry aficionados. And the other pleasure principle, dopamine, is when we are happy or when we eat a piece of chocolate or what have you. That's when dopamine is stimulated. Serotonin has been associated with depression, and the other workhorses, which are the acetylcholine and the other transmitters, which are formation of memories, called glutamate, which is the amino acid, and endorphins, which just makes us happy, which is related when you exercise. Okay, so all this, and there are other smaller transmitters, you know, type of things, and the list is quite long, but okay. again, and so there are the varieties of pathways. The one is the so-called dopamine pathway, which is related to a reward, pleasure, and fine-tuning, etc. While on the other hand, serotonin pathways are related to memory processing, sleep, so and the hippocampus is formation of new memories. So these are the varieties of pathways that are involved, and and obviously, if there are degenerative changes in any of these parts, then a lot of time, as with dementia, people cannot form new memories. And also at the same time, there are varieties of genetic as well as environmental disorders such as Parkinson's disease. So that is characterized by stiffness of the body, slowing of the movements, trembling of the limbs. Okay, and so these are, some of the and that has a lot to do with the uh, absence of dopamine. And obviously, the classical movie that was done by Dr. Oliver Sacks about the uh, epidemic of encephalitis that occurred in 1919, and with the administration of the dopamine analog drug L-Dopa, he was able to revive these patients for a short time, and then unfortunately, then with the larger dose, they got side effects, and that's why the study had to be terminated. Okay, so and L-DOPA stands for L means levo, the way the chemical reflects lights and rotates. That has to do with a lot. And now, obviously, and a lot of us are familiar with some of these drugs which are used as become workhorse of depression called serotonin, SS selective serotonin inhibitors. And the most well-known are, which has become the common knowledge word, which is the Prozac. I think one of the ballet dancers wrote a book, Dancing on Prozac, which came out about 20 years ago or something. Okay. So, and that is, and now recently there have been some data that it may not be on as solid foundation as we thought it to be. So the trend in psychiatry is now to wean people off the SSRIs, with cognitive behavioral therapy. Okay. And again, so these are, just some of the more chemical pathways as to how the hippocampus secretes varieties of hormones that not only just works locally on the brain, but also works on the other glands, which is the adrenal glands, which sits on top of your kidneys and secretes adrenaline. That's why it's called adrenal. Ad means on top of the renal means kidneys, and has also direct bearing on your immune system. Glucocorticoid steroids are ubiquitous and are necessary for formation of varieties of responses in your human body. Okay, and the serotonin pathway has, again, as we alluded to earlier, the it has a lot to do with depression, and depression is been with mankind, and there are some famous depression sufferers called Goethe, Newton, Dickens, Van Gogh. So and the list is, wide. And at the same time, there are other illnesses when there is lack of dopamine, which is called anhedonia, okay, which is the inability to feel pleasure, okay, type of thing. So this is, and again, with some of the other things, there are seasonal affective disorders, which again lead to depression, and your sleep and circadian system, which has a lot to do with, with the hormone called melatonin from your brain, and a pituitary that has to do with your body clocks. Okay, so there are varieties of chemicals that are intricately involved in a very finely tuned mechanism. Okay, all right. Okay, now there are some of the mutations that were isolated with inability to walk, walking gait, which is, related to Icelandic horses that they have this type of gait, and which has to do with, and so there are varieties of mutations that have been isolated, and genes eventually form protein, which is called DMRT3 protein, which identified something called interneurons, which is a connected one neuron are connected with other, with something called interneuron disease. And finally, this same disease abnormalities have been isolated in a rare disease called Charcot-Marie Tooth disease. Charcot was a very well-known, famous French neurologist. So how basic science is connected with what has been seen and applies directly to human health and disease. Okay, and now you can see.
Rajit Ulash has fathered 19 children, a lot even by local standards in this remote Kurdish village.
It's wonderful.
12 of them were born totally healthy, but 7 weren't, 6 of whom survive. And the first hint of the problem soon appears from down the road. This is Gulin. At first sight, he looks drunk. But he isn't. There's something wrong with his balance. Still, he's on 2 feet, not 4. But then, one by one, the other children appear. There are 4 young women and 1 young man. Hussein has walked like this for 28 years. No one knows for sure when our ancestors stood up, but there are clues. One of the most haunting is this trail of human-looking footsteps, unearthed in Tanzania. Whoever made them walked on 2 feet, and they are more than 3 million years old. Many people think that...
Okay, so you can see this is a fairly long tape, but this is a tragic disease as to how genetics and human evolution ties in. Okay.
Well, that's debatable, but...
No, I don't think so. There was always the question of whether our ancestors came down from the trees as bipeds and walked on the land already fully pre-adapted to bipedality, or if they actually underwent a quadrupedal stage in between, where they actually walked on all 4s. And while a congenital anomaly can know 1,000 years apart if they belong to the same species.
Okay, so here's a link for those of you who are interested in this tragic illness that has affected human beings as well as in the rabbits. And you can see that finally we are getting down to the molecular basis of this abnormality. Okay, and now we'll talk about the sensation as to how the eye is anatomically, it bothered Charles Darwin as to how it was sort of backwards, type of thing, and that the impulse comes in from outside and the image is upside down, and the retina, the sensing part, is at the back behind all this vitreous liquid, and the nerve fibers, and there's in the middle, there's kind of a blind spot in the middle, type of thing. So And this was discovered quite a ways back in 1668. Okay, and as you can see how the varieties of nerve cells are the bipolar nerve cells and the rods and cones, which work, with light sensing mechanisms, Okay, and so there are like, and for the color vision, there are the rods and cones. Okay, and we have like as many as 5 billion of them. And obviously, if you have genetic abnormalities, then you end up with, a red-green color blindness. Okay, so this is, the basic mechanism of how the image is processed and the photons are, and it causes the electrical changes, and then creates a signal that is transmitted directly to the brain through the optic nerve, as you can see at the back. It's just really extension of your brain, basically. Okay, and as the impulse that travels, from the eye, it initially goes to the temporal part of the retina, and then via the optic nerve. This is the optic tract, and then the optic nerve. Then it goes down further, and it crosses over. Let me see if I can zoom this. Visual field is divided into two areas. The temporal means on the outside, and the nasal means the medial part, the inside part, and then it and the axons extend, and the optic tract consists of having passed through something called the optic chiasma, where it crosses over. Then it becomes like a large fibers of nerve, and gets into the visual cortex, where it is processed. Okay, and so now the brain actually does a lot of processing. That what you see is about the 10% of it comes from the optic nerve. The brain fills in and tries to make sense out of the impulses that are taking place. So brain sort of looks and has to see what the future is going to be like, and trying to kind of save your body from further damage. So, so there are like the two radiations that took place. This is a slide that is taken from a Harvard vision specialist named Dr. Livingston, as to see how there are two radiations that come from retina, which is the Watt system and the Y system. So there are two pathways, to where, which has to do with the depth perception and the varieties of higher visual processing areas that are in the parietal region. And the earlier part, as to what, we are recognizing the object and the face and the color. So there are two main pathways, how the brain tries to interpret the information that is coming in. Okay, I think we'll stop here for the time being. Okay, so this gives you some idea about how, so we are kind of programmed to see varieties of shape, and face, and so there are varieties of optical illusions that takes place, and it's tons of literature on it, but I think, I talked at length about it when we talked about the senses class. Okay. Now, again, now getting to the other equally important sense.
Your ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates 3 tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize. Ear catches the waves, which then travel. Different hair cells respond to piccolo or flute, progressively lower pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize. Ear catch.
Okay, now there are varieties of ways to study the brain, and in the old days we just had primarily skull X-rays, spinal tap, and EEG, or the brainwave test. But now the recent thing is obviously the CAT scanning and the functional MRIs, which is where the actual oxygen in the blood and the activity of the neuron can be judged. Okay. And this is, like an MRI type of movie, as you can see, that it's the magnetic, which has to do with the, how the protons respond, the water in the brain responds to the shift in the magnetic field. And you can see how the details are exquisite. You can actually get the inside view of the normal as well as the abnormal anatomy of the brain. Okay, and so it depends upon the blood oxygen level, and it gives what is known as a good spatial and means the location and the good temporal resolution. And there are other types of images which are done and which have to do with various technological things are involved in it. And MRI has been a challenging and interesting field, and it has been rewarded with at least 6 Nobel Prizes at different times. Okay, and it has complemented us dramatically in terms of studying the brain function during real time. Okay, and this are some other ways.
These researchers are using clusters of neural cells called brain organoids because they have many of the characteristics of a developing brain.
These are brain organoids. We call them brain organoids because they develop similarly as a human brain. We don't make these organoids by putting cells together. We just give cells the right conditions to grow, and they organize themselves into these structures. Like many stem cell researchers, we first start with induced pluripotent stem cells. These are made from a mature cell, such as a skin cell. The skin cells are given different factors and they become pluripotent stem cells. To generate brain cells, we provide specific growth factors to guide the cells to become neuroprogenitors. These cells are the first step in brain development, and you can create all types of brain cells. First, these cells self-organize into neural rosettes, and we keep providing them with nutrients and factors for them to become healthy, mature neurons. As these rosettes grow larger, the cells form different layers that are similar to the ones found in the brain cortex.
These brain organoids are the focus of these researchers' many investigations.
Okay, so this is, and so this is, these are very tiny, so they are certainly not going to take over the mankind, and they're just less than a few millimeters. So this is like 10,000ths of the volume of an adult brain. So I don't think Caesar from Planet of the Apes is going to take over at any time soon. So, okay, and so this is an easy way to study disease processes as well as to do drug testing, by the way. Okay, now again, it's the important function of brain is brain needs to recover and kind of clean out the garbage. So the important thing was the varieties of stages of sleep, and something called the rapid eye movement sleep is equally important, and without sleep, you probably would not even last and would, really some serious physiological consequences occur without sleep. And people have tried, doing some silly records of that. And, I think the longest was about 20 days or long, something like that. Okay. In the stage one, where the eye movements are slow, and then we get into deeper stages. And then there's something called the rapid eye movement that takes place toward the end, and most people can actually remember that dream type of thing. And the restorative sleep, which is the deep sleep, in which the brain actually turns off various modules. And again, as we all get older, insomnia becomes a big challenge. And now there are some rare conditions where people actually have inability to sleep due to genetic abnormalities called fatal familial insomnia. Okay, and that's, you could say, it's literally fatal. Unfortunately, it's very rare. It's described as far back as 1836. Okay, and then again, within 6 months, this particular person in UK developed cognitive decline, and died shortly thereafter. Okay, and as recently as a young woman who's a trained lawyer, her mother had the same illness, and so decided to switch the field. And she and her husband have changed career and are doing molecular biology research on this particular genetic abnormality. So it's fortunately it's very rare. So, and you can see how the brain and thalamus degenerates. And then this again, some rare families in Italy have been diagnosed with this particular illness. And this here we are illustrating the importance of the melatonin and the hypothalamus, which is secreted, and affects the other organs in the body called adrenal cortical stimulating hormones, the adrenal gland, and eventually cortisol is formed. And you can see that there are areas in the brain which are sensitive to light, which is called suprachiasmatic nucleus, and it releases the various hormones called corticotrophin release hormones. Okay, and so these were discovered, how the body kind of gets ready to face the day, and this was discovered as recently as 1972. And so they're getting sensation from the eye in the daytime. So then there actually are people who are the so-called early morning risers and late sleepers, so to speak. So, and there are particularly how the body is tuned to do certain activities at a particular time of the day. As you can see, how you have more, awakeness and coordination, reaction time, and this is well proven, when you time travel or with jet lag, so to speak. And this has been proven in the record of teams that traveled across the United States to play games, and the performance is definitely affected by the change in their circadian rhythms. As you can see, in the early morning hours, the body temperature is low. At 2 o'clock, you're under your deepest sleep, and in this rise of melatonin secretion that promotes sleep, basically. Okay, and again, the sharp. As soon as you get up, your body gets ready to face the activity of the day. Melatonin secretion slows down. The blood pressure rises. Basically, sometimes you get a reflex. You have testosterone. You become more alert. Okay, and so the whole cycle continues. So it's a very finely tuned mechanism. Depends upon the exposure to light, and so much so that people who are night shift workers, they certainly have some serious physiological side effects and illnesses. Okay, now getting to the more important parts, there are varieties of types of memory that the psychologists have associated. There are the short-term, so-called working memory. So this is like the RAM chip in your computer, the long-term memory, which is your hard drive. And there are varieties of memories, which are the procedural memory, which has to do with like the car driving, which gradually becomes, and the declarative memory, which, where you remember as to which is specific to your particular purpose. Episodic memory, okay, which, depends upon your personal experiences as to when you're born, as to the serial time sequences given to the time. So, and it's kind of an autobiographical events that takes place. And the procedural ones that we already talked about, type of thing. Semantic is more structured record of facts, meaning, concepts, knowing how to know the outside world. It's like when you answer questions on Jeopardy quiz. Okay, and the role of the primary forming new memories is the area is called hippocampus, which looks like a seahorse. Basically, it's a small organ in your midbrain region. And there was a particular patient who had, as a result of epilepsy and damage to his hippocampus, and he could not form any new memories. Otherwise, he was functioning adequately. But the physician who took care of her, every day she had to reintroduce herself, type of thing. So that is, hippocampus is extremely important in with dementia patients because they have the old memories, which are hardwired, but they cannot form new memories. So if you ask them what they ate for breakfast, they won't be able to tell you. But at the same time, they'll tell you what happened 40 years ago. Okay. Again, the process, every neuroscience book has a reference to this, about this unfortunate man who lived in the 19th century, who had a big steel rod, was working on foundry, and it went through his brain and came out through his eye, and actually, fortunately or unfortunately, he did not die, but his total personality changed. That after that, he was a reasonably, well-behaved citizen, and then he just became abusive. His total personality changed, and it was a dramatic. So this was a kind of he wasn't able to work as a foreman, and then again his health began to fail. Okay, and he began to have epileptic seizures, and again, so this varieties of it showed how the bar went through his brain, type of thing. So. Okay, and there's a very long story about it, that I've included in my notes, those of who are interested in type of thing. So, okay, and so it showed the importance of the frontal part as to for the memory formation, for making us who we are, for giving us our personality. Okay, again, the most important problem in the brain is that the neuroscientists, philosophers have not come to the term as to what actually constitutes consciousness. And an Australian philosopher, showed about the idea of the so-called the sensation of, like, when you see the red color, as to what gives the sensation of the color type thing. That's something called qualia, and it's described as the heart problems. And so the easy problem was just basic, day-to-day activities type of thing. So those are some of the things, and people still have, there are varieties of theories of consciousness, and the reason why there are so many is because there is no one that has been proven some a true type of thing. So, and again, the correct model for memory is when you're in anesthesia, or people who have the so-called locked-in syndrome, or those who are under coma. So there have been good models for studying consciousness type of thing. Okay, all right. Now getting back to the other parts, which is one of the common causes of illnesses. There are 2 or 3 different types of strokes. One is called ischemic stroke, which occurs as a result of a blood clot, and the transient ischemic attack, which is so-called mini stroke, and hemorrhagic stroke, which can occur as a result of aneurysm. And obviously, as one can understand, this is the most serious kind. And the ischemic strokes are a lot more common. The hemorrhagic is fortunately rare. Okay, and that can be. This can come from a blood clot that forms somewhere in the body, usually in the heart, and due to irregular rhythm, and can form and go into the brain and block the blood vessels that we saw earlier, and can cause stroke. And the earlier days, when blood pressure was not well controlled, the hemorrhagic stroke was very common. Okay, but with the improvement of treatment, and now the clots have become more frequent. And the new treatment that arrives is dissolving the blood clot with blood thinners, and where the time is of essence. Okay, and the sooner, because every minute that your brain is deprived blood supply, the neurons are dying and they're hard to regenerate. Okay, and again, getting to the more common illnesses, which are the headaches and epilepsies. Okay, all right. And the typical and the classical headache that is known as migraine, which is associated with aura, which are the disturbances in front of your eyes. half the brain has a throbbing sensation accompanied by cannot tolerate light, sensitive to noise, and sometimes it runs in the family type of thing. So there are migraine. Okay. So this is very it is 18% of women and only 6% of men suffer from this. So there are varieties of, you can see how this that pictures that the people have drawn, that the visual fields are disrupted. Okay, but there are varieties of treatment that are available, and the headaches are divided into, it's to be the history as to what the headache was like, the description and the examination by the neurologist is extremely important, as the most intense headaches are associated with tumors, and that the migraine headache, the history of aura is important. So a good clinical examination and description is extremely important to come to the conclusion. Okay, and there are varieties of, you can see how the aura, the premonitory symptoms people can get with yawning, increased urination, aura, where they can see the visual sensation, headache, and then the later on symptoms that take place. Okay, and so this is, and there are varieties of other illnesses called trigeminal neuralgia, which is where the nerve is irritated type thing. So that, varieties of disease pathologies, and how the disease is classified to clearly diagnose migraine. You have to have X number of attacks and associated other symptoms to come to a clinical diagnosis. Okay, and the identifying precipitating factors can be either stress or oral contraceptives, extreme glare, fatigue, certain foods which are high in cheese or salt, lack of sleep. So they're associated with triggering factors. And the treatment of migraine has been wide and varied. I know study from aspirin to ergot, which was called St. Anthony's fire, and the varieties of other medications have been used. And sometimes the neuromodulatory devices in introducing nerves, type of thing, and with electrical stimulation of the area have also been tried. Okay, and the earlier drug which were done, in 1906 with ergot, which is a type of a fungus that was used earlier. Okay, and migraine was due to increased adrenaline activity, so that's why the ergot type of drugs were used by Swiss pharmaceuticals. Okay, and now there are varieties of peptides have been diagnosed, have been synthesized lately, and these are the new so-called monoclonal antibodies, which are much more specific, at treating migraine. But at the same time, being a newer drugs, they are quite expensive. And some of the worrisome headaches, they start abruptly at a later age, okay, and they are associated with nausea, vomiting, and they have a stiff neck, and they can be either due to meningitis or due to a new onset of tumor. And obviously the brain aneurysm can be, rupture can cause intense headache, and unless treated promptly, can lead to death very quickly. And the classic example was the British actress who turned out medical treatment from a skiing accident, Natasha Richardson, who died promptly within a few days due to brain herniation.
Now a widower. Husband Liam Neeson returned home after the death of his wife, actress Natasha Richardson. Her mother, Vanessa Redgrave, soon followed. Richardson suffered a head injury Monday while taking a ski lesson in Canada. She was pronounced dead Wednesday at a hospital in New York. The family did not give specifics about the cause of death, but Liam Neeson did release a statement saying the family was shocked and devastated by the tragic death of their beloved Natasha.
Okay, so that was, due to not getting prompt, neglecting the serious. Okay, and there are varieties of other illnesses which are called autoimmune type of diseases called inflammation of the blood vessel in the brain, which is called temporal arteritis, which is a classical headache that can occur, and that can cause even blindness unless diagnosed and treated very promptly. Okay, and varieties of features, which are important to the people who are looking after the patients. Coming back to seizures, epilepsy has been around from the Roman era. As you guys remembered from Julius Caesar, was one of the earliest well-documented victims, and where the certain set become hyperexcitable and they fire in synchrony, causing a seizure. Okay, and it can be due to either abnormal electrical focus or due to other tumors such as brain tumor, genetic abnormality, metabolic abnormalities, and so on and so forth. Okay, and there can be just a focal, means a localized seizure, or it can be generalized, called grand mal seizure. Okay, all right. And there are varieties of other causes that we already alluded to in older individuals. Obviously, stroke and brain tumors take priority. In kids, it's metabolic abnormalities, lack of oxygen, etc., would play a role. Okay, and these are just some of the guideline principles as to how it should be treated. And the airway maintenance is extremely important, along with. Okay, all right, and so this is, and really prompt medical attention is required. So, and for the refractory epilepsy has required, sometimes it's drastic enough that it does not respond to drug and requires even brain surgery as drastic as separating the half the hemisphere type of thing. So this was one of the classical ways in which the brain mapping was done. While during some brain does not have pain fibers, so during surgery, surgeons were able to meticulously map the areas where the sensory impulses end. This is how the concept of the so-called homunculus was formed. As you can see, the brain has a large representation of more sensitive areas, such as your finger, your face, with the areas which are more sensitive that represented, they command the large areas of the parietal and the motor cortex. And this was discovered by a well-known Canadian surgeon, Dr. Penfield, and these are still called Penfield maps. Okay, and the famous stroke victims, Winston Churchill, Roosevelt, Stalin, and so it's been around for a long time. Okay, the transient ischemic attack, where you have a sudden onset and then it goes away within less than 24 hours. That's why it's called transient. And it depends upon the location of the blood vessels. And the varieties of aneurysms that are described based on the anatomical, saccular, the fusiform, mycotic is related to fungus. And usually, sometimes people are born with the arteriovenous malformation. You can see how this little bulging, it almost looks like a balloon that's ready to rupture. When it ruptures, we are left with some disastrous consequences. Okay, and the stroke is, one of the major leading causes of death. Again, 34% people are of younger age, obviously causing smoking, high blood pressure. Okay, and the early treatment is extremely important. And again, so stroke, the left side causes aphasia, speech expressive aphasia, which is called Broca's aphasia, and this was due to Broca's area type of thing. And the Wernicke's area is close to the auditory cortex, as you can see around here, the red part. It is associated with difficult with comprehension. They receive the information, but they are not able to. Broca's is in the motor speech area, in the motor cortex. So it lies in the speech in the front part. So okay. And so these are the two ways. Now sometimes when the stroke is affected, people have this so-called right-sided neglect. So you can see how they're asked to draw the clock. They only draw half of the circle. They're missing half, or they will eat only half-side of food. So it's called left-sided neglect. The right stroke on the right side of the brain. So this is how the art of diagnosis and the understanding of the basic anatomy is extremely important. Okay. And the stroke awareness, it's like, ways where, the facial drooping, your arm weakness, your speech difficulty, and the time to call. So these are the way it is important for heart. It is equally important for the stroke to get prompt and effective treatment. Okay, and these are just some of the blood vessels. You can see how that there's the bilateral symmetries, missing type thing. The blood vessel actually has a sharp cutoff at the point. There is no blood going on that side, due to blood clot. Okay. And there are varieties of other treatment that are available. One is called the clot dissolving medication. But if the clot is massive and large, the surgeon or the radiologist in this case has to go and remove the clot.
your chances of being back to normal or near normal is close to 50% with the treatment. If you have no treatment, the chance is just like 13%. You're not getting exposure on, I know what. So essentially what you do is most of the time you go through the groin artery called the femoral artery. We get inside the blood vessel, and then under X-ray guidance, you can guide that tube all the way to the neck. We shoot contrast dye, we then can take pictures of the brain blood vessels, locate the site where the blood clot is occluding the main artery, and then you would put the stent retriever. They essentially look like a wire mesh, and then the clot gets engaged, integrated in the wire mesh, and then we can remove everything as a unit, and then hopefully the blood clot is completely removed. That procedure can be as quick as 10 minutes to 20 minutes. This was a patient that.
Okay, so this is one more aggressive way to treat, but obviously, not all centers are qualified to do this. Okay. and this is just shows how the disease pathology, the blood clot dissolving drug meets with certain other proteins in the body, which is called plasminogen, that is activated and turns into a plasmin and breaks down the clot forming the fibrin, and we just gradually dissolve. Okay, so this is the basic pathology of the clot dissolving medication, and this was the drugs came into existence in 1982. And they were approved for a stroke, almost 10, 15 years later. And the clot retrieval had only became popular in 2014. At that time, you had to get to the hospital within 4.5 hours. And now the trial has gone up that, you can even increase the time for as late as 12 hours. So the varieties of studies done all over the world, which have shown as to the earlier is better, of course, but the time window has been extended somewhat. And again, COVID has affected the brain also. As you can see, that there are some varieties of long-term sequelae that have taken place, and brief communication. And there's a rare illness that can occur with a small percentage of people with vaccination called Guillain-Barré syndrome, which is a total paralysis that occurs with including that of respiration. Fortunately, that's a very rare illness, I think. Again, and now there are varieties of technology that have been tried with called brain-computer interfaces called spinal implant that have allowed people to stimulate of almost a dead spinal nerve with electrical signal, and the brain has enough plasticity that the nerve signals from brain to the legs are sent down, and these signals are weak, and with training the spinal cord, there's enough plasticity that people are able to walk. But then this is obviously some of it is experimental, but the results appear to be very promising. And so, okay, all right. Now, last but not the least, dementia, which is a major health issue with aging population. And you can see the numbers are increasing, and the cost is nothing sneeze at. Alzheimer's takes priority, but there are other degenerative diseases which need to be clinically distinguished. Huntington's, which is a genetic disease and it's rare. The prion disease, which occurred due to the mad cow disease type of thing, and some of the illnesses that in Papua New Guinea with the consumption of the human brain. Okay, so those are, unfortunately, those are rare. Alzheimer's and vascular dementia is more common with aging. There are other types of dementias that need to be clearly distinguished because the treatment approach is different. Okay, sometimes Parkinson's is an old disease, which has got to do with your cerebellum, and which we already talked about. The pigmentation takes place with the lack of dopamine in certain areas. Okay, so but that's a more treatable illness. Even those patients can get sometimes dementia. Okay, these are some of the criteria for something called frontotemporal dementia, which occurs at a younger age relatively, and they have something called behavioral apathy, expressive aphasia, and that overlaps with Lou Gehrig's disease or amyotrophic lateral sclerosis, and there are varieties of protein abnormalities that takes place. The protein folding is extremely important type of thing. So these are some of the clinical criteria that you can read at your convenience if you're interested in more details. Okay. Alzheimer's disease, obviously the poster child of that was Ronald Reagan and Maggie Thatcher, and the memory loss, which occurs unfortunately, there are two types. The one occurs, which is genetic, it can occur at an earlier age, but the other one is related to age, gender, and the inflammation seems to be the big thing. And people have worked a long time on Alzheimer's, thinking that it's the amyloid and tau protein, which are the things, but attempts at reducing that have been very, very, frustrating, to put it mildly. And so far, in spite of billions of dollars and thousands of people's research, only no really drug has been on horizon. And the old treatment that we still have do not slow down the disease, may just treat symptoms a little bit. Okay. As you can see, that the abnormal proteins accumulate gradually, and the more recent theory is that the disease process starts very early, and by the time these abnormal proteins called amyloid and tau appear, as generally it's too late to intervene, type of thing. And at the same time, there is a discrepancy between pathological finding and the actual clinical symptoms. That was proven in the nurses study, and the nun study rather, and who volunteered to donate their brain. These were long-living nurses somewhere in Southern California. And even though their brains had dramatically changes similar to Alzheimer's patients, they were still functioning normally. And that may have got to do with their social interaction, ability to engage. And so it just, the anatomy does not match with the extent of the clinical symptoms. Okay, so it's maybe a lot more complicated, and the varieties of area, hippocampus, which makes the memory loss, and then it gradually progresses. And finally, people became almost in a fetal position, and then they stop eating and just waste away. And so it's a very tremendously. Now, still, sometimes it's interesting that the music response is still maintained, even though, and there are varieties of complex ways. There are some blood tests have been proposed, and it seems to be quite accurate now. So it avoids the need to do spinal tap or the more complicated tests called MRI scans. And this is the histopathology. This is called beta amyloid plaque, and the varieties of tangles they form called twisted, tau protein tangles. And so there are varieties of protein misfolding disorders. There has been some associated with herpes simplex that has been proposed. Okay, and this was a very recent finding, by the way. So sometimes inflammation may have set it, and the brain is not unable to clear all the garbage, so that may have more role to play. Okay, and so these are the brain's lymphatic system and the drainage system, and the microtubule may have more role to play. Okay. And the brain definitely shrinks. You can see the disease pathology, and it can be extreme as it goes around. You can see how the two pictures look dramatically different. And there's something called the early onset Alzheimer's disease, which is a really genetic disease type of thing, but fortunately it's very rare. Okay, late onset is more familial, and again, that no clear-cut in-head spread has been identified, and it can last for 8 to 10 years, and becomes really difficult to look after this. Okay, and sleep is extremely important, because during the sleep that the brain clears out a lot of garbage. And recently, the so-called glia lymphatic system has been proposed, which cleans out all the garbage. So lack of sleep has a dramatic role to play in creating Alzheimer's disease at a later age. As the minimum 6 hours of sleep is important to be emphasized. And some varieties of protein that is called ApoE4 have been implicated, that if you have 2 copies, your chances increase substantially. But there are more genes than just ApoE, so it's not as straightforward. It's not just a simple carrier of lipid, but and it has a lot to do with the inflammatory process type of thing. So, and this protein is equally important and has a relationship with your heart disease as well. Okay, and so the varieties of genotypes have been proposed as a risk factor type of thing. Okay, and okay, now this gets to be fairly complicated type of thing. So this is, I think we'll skip that. And recently there are varieties of drugs that are being proposed, but none of it, it's a more expensive monoclonal antibody drug that was released by FDA, even though the committee was not unanimous in recommending, but the data on that is very wishy-washy, to put it mildly. Yeah, and this is the new drug that was released in the market as recently as January of 2021. Okay, it's the monoclonal antibody type of thing. So, and there are some newer drugs that are approved in China, but again, as we don't trust the Chinese, so they're still not seen in the U.S. market. Okay, word or two about Parkinson's. It's an old disease with tremors, bradykinesia. It's typical classic posture. Okay, constipation is related, and in the area called on the midbrain called substantia nigra, black pigment develops. And that is the autopsy finding of it, and it's a treatable illness with varieties of diseases. Okay, and again, the well-known victim is Michael J. Fox, who has a full foundation for supporting it, because some of these drugs, after a while, the body develops tolerance, and the deep brain stimulation has been dramatically effective in treating some of these tremors. Okay, and here's a nice example of it.
Treatment of Parkinson's.
Open and close.
David had probably the worst tremor I've ever seen from Parkinson's disease. It's a very high amplitude tremor and with high frequency. He was a very normal, nice guy. Couldn't stop shaking, completely wet with sweat the first time I saw him walk into the clinic.
Parkinson's for about 11 and a half years. I said, there will be a cure someday, but this is my cure for now.
So you can see how the electricity of the brain, the stimulation of the right area would be excellent surgical outcome that he has received.
Treatment.
Okay, and there are varieties of stem cells that are being tried for Parkinson's disease, and it looks promising. Okay, and last but not the least, Lou Gehrig's disease, amyotrophic lateral sclerosis. It starts at a relatively younger age. Varieties of risk factors have been proposed, and there is some treatment available for it, but otherwise there are no still traumatic cures that have been. Multiple sclerosis associated with mononucleosis, Epstein-Barr virus. Again, it can be three types: relapsing, progressive. Okay, happening, and these are the MRI scans, which shows the degeneration in the brain. Heredity has, and Northern European population has a bigger impact. Females are much more likely in the temperate climate. Pollution may have some role, and variety. It's a patchy disease, so it's hard to judge the treatment success rate. And it's again related to Epstein-Barr virus, as we talked about. Okay, and now sometimes this has a lot to do with the so-called stimulation of the brain, and a scan of a dying human brain was how the light flashes out over his eyes. So this may have explained how the so-called near-death experiences. Okay. Last but not the least, the consciousness. It's a varieties of stages from general anesthesia and coma, where you're not conscious and you're not awake either, to varieties of stages from deep sleep, light sleep, to drowsiness, fully conscious, to minimally conscious stage where you're not awake, where you're awake but not conscious, and the vegetative state, which is, again, we are so-called locked-in syndrome type thing. So there are varieties of stages that have been rarely proposed as to whether you're awake or conscious. There's a huge difference between the two, and how they are when they both are on the upscale. That's when you're fully conscious. Right? So you can see how under general anesthesia you're not awake, and your consciousness level is down, and you can see how the sleep falls somewhere in between. And last but not the least, the word of neuroplasticity. There was a woman in China who was born without cerebellum, and she was still able to function reasonably well. Okay. So.
Je vous appelle de la part d'un de mes patients, Monsieur Jean-Dominique Bobby.
Jean-Do, comment va-t-il?
Ça va.
Mais c'est affreux, on m'a dit qu'il était complètement paralysé.
J'étais même plus capable de communiquer. Oui, non, c'est pas tout à fait exact.
Oui, entrez. Pardon.
En fait, je vous appelle parce qu'il se demandait si vous pourriez faire quelque chose pour lui.
Mais bien sûr, vous attendez une minute.
Il dit qu'il a signé un contrat avec vous pour un livre.
Il dit... Mais il parle, je croyais qu'il pouvait pas parler.
Il parle, il s'exprime d'une certaine manière, je vous expliquerai. Au sujet du livre...
Il a conclu un contrat avec nous, mais vu les circonstances...
Il faudrait le faire. Il veut écrire un livre.
Mais c'est pas sérieux, c'est pas possible.
Mais oui, je vous assure que si. Mais est-ce que vous pensez que vous pourriez trouver quelqu'un qui écrirait sous sa dictée, quelqu'un de patient, de... Il faudrait quelqu'un qui puisse être là tous les jours. Vous voyez, c'est quelqu'un de particulier.
Oui, je comprends. Je vous rappelle.
Betty Mialet dit que Claude Mindibile est une envoyée du ciel. Elle a affirmé que c'était la personne rêvée pour ce travail.
Betty exagère toujours. Faut que je m'exerce encore, je vais travailler avec Henriette.
Quand vous voulez. Ça va aller vite. Hein. Il veut dire quelque chose? E-S-A-R-I-N-T-U-L-O-M-D-P. E-S-A... pas. E-S-A-R-I-N-T-U-L-O-M-D-P. E-S-A... E-S-A-R-I-N-T... E-S-A-R-I... Pas de panique. Claude a pris une chambre d'hôtel à Berck. Vous devriez décider comment vous allez vous organiser.
L'infirmière me réveille à 5 heures du matin.
Bonjour, monsieur Bobby.
Je penserai à ce que je veux écrire et je l'apprendrai par cœur. Vous n'aurez qu'à venir à 8 heures. Et je vous dicterai ce que j'ai préparé.
Entendu. Je ferai de mon mieux.
Moi, j'en suis persuadé. On peut commencer demain?
Bien sûr.
E-S-A-R-R. E-S-A-R-R. E-S-A-R-I.
Du petit matin, j'ai mal au talon, la tête comme une enclume, et une sorte de scaphandre qui m'enserre tout le corps. Ma tâche consiste maintenant à rédiger les carnets de voyage immobiles d'un naufragé échoué sur les rives de la solitude.
So this was a movie about a real life story about a man who was in the locked-in syndrome, and just with blinking of his eyes, he wrote an entire book, and it just shows the story of the human endurance and desire to communicate. Okay, and last but not the least, for depression, electroconvulsive therapy was used, but now there is transmagnetic stimulation. That's the new technique, which is a lot more acceptable. Okay.
Magnetic stimulation, or TMS, is a procedure that involves rapidly alternating magnetic fields focused on certain areas of the brain. And when we do that, it induces a stimulating electrical charge on the surface of the brain with an effect that eventually, over time, has a positive benefit for areas of the brain responsible for mood. TMS does require frequent visits, actually daily, 5 days a week for 4 to 6 weeks for a typical treatment course. So it does require a time commitment, but for people able to do that, they do stand to benefit from TMS when they have not benefited from other treatments in the past. The treatment itself lasts just under 40 minutes. The entire appointment typically lasts about an hour from start to finish.
Okay, so this is, there are the varieties of neuroprosthetics have been devised with bioengineering and electrical engineering collaboration of, getting in the sensory input as well as the motor output, So this is the way to the so-called neuroprosthetic. Starting obviously the prototype was the cochlear implant for hearing loss. At the same time, to going to the more complicated, the vagus nerve stimulation for epilepsy and deep brain stimulation, which we already saw. Okay, and then there are other stem cell implants. So varieties of approaches of regenerating brain tissue have been tried with the collaboration of multidisciplinary approach. Okay, so we are coming to the end of this, and next time we'll talk about heart disease in general. So I will stop the recording at this point and we'll continue.